So we are starting out with properties of exponents. So hopefully last night you're feeling a little well-versed in them after remembering all that. So we're just going to keep using those properties. I'll go over all the properties again to start. It's the first thing we're going to do. And then we'll just kind of keep putting them together in some harder problems and see how we're doing. All right, so the first property, the product of powers property. Now, if you came from geometry, you're thinking, oh my gosh, do I have to memorize all these titles? Are we going to do proofs in here? I'm going to have to do all that stuff? No. I don't care if you know the title as long as you know how to do it. That's all that matters to me. It is called the product of powers property. I would not know that off the top of my head without just reading that. I know the property. I know how it works. That's all I need to know. All that's saying is that if it has the same base, do you guys know what the base number is? That's the big one at the bottom, right? So if those are the same, then what allows us to do is it stays the same. So the a didn't change. It's still an a. And the m and the n, the exponents, you actually add them. Okay? So for example, if I had 5 squared times 5 to the third, does the 5 change? No. Good. 5 to the 5th, right? The base stays the same, and then you just add their exponents. 2 plus 3 gives me 5. Okay, so that's that property. The biggest thing I see students mess up on is a problem like this. If it's a variable, they do great. They're like, yep, x to the whatever stays an x. Suddenly I throw a number at you and they want to add it or multiply it or do all kinds of crazy things to it. It just stays the same. All right, the next one is the power of a power property. I have 2 exponents for 1 base. So for me, when I see something like this, my first instinct, I think of, if I gave you this, 3 times x plus 2, what would your instinct want you to do with that? You would distribute. Distributing is what property? Or what operation, I should say. It's multiplying, right? That's like your instinct. Hopefully at this point in your math life, you see this, oh, I need to distribute. Same thing here. When I see this, I think I need to distribute. And that's really what I'm doing. I'm distributing it to here, and it's the same way I would multiply up here, I'm multiplying there. Do you ever multiply an exponent to a base number? No. I cannot tell you how many students do, and it's very, very wrong. Okay? Exponents are snooty. They only like people of their kind. Exponents only like exponents. Okay? So like if I would have 7 to the third and all of that to the fourth, what would that become? 7 to the 12th. Right? You multiply. Right? Power of a product property. Same idea. If I have more than one base inside of there, it gets distributed. The same way you would distribute up here, it distributes down here. It's going to distribute to each piece in that base. Okay? Again, for example, if I would have 5x, all of that squared, how would that distribute? I didn't write any exponents inside. Does that throw you? What's its exponent if it's not there? It's a 1, technically. So technically, this is 5 to the first and x to the first. So it's going to distribute and make that 5 squared. Distribute to that one and make that one x squared. I think that's the biggest thing people mess up on. Usually when I give a problem like this, they'll tell me it's 5x squared. They'll distribute to that x, but they forget that each of them's individual pieces. The negative exponent property. We can never leave negative exponents. They're considered not simplified in math. So to get rid of them, all you got to do is move them. I always think about it. I like to have like really weird ways to remember things. You'll learn that about me as the semester goes on. You know, the more strange it is, the better like you remember it. You know what I mean? Like the more off the wall. So for here, I always think of negative exponents. It's like somebody did something wrong and they're being punished. So you get sent down to the basement to be punished. And then you learn your lesson when you're down there. I know it's twisted, it's weird, but it helps me remember it, right? So this is a negative exponent, that's bad. So he gets sent to the basement, flipped underneath there, and now he's positive. It changed his mind. What if it's negative on the bottom? What if I have like 3 over x to the negative 2? He flips up to the top. He likes the basement. All of his game systems are down there. So to punish him, you're going upstairs away from all your stuff, right? So he gets to move upstairs, and it would just be 3x squared. There you go. Either way, if we want to think about that. But just If it's negative, move it. Can the base number itself be negative? Is that allowed? Could that be a -3? Would that be okay? It can. What's not allowed to be negative? The exponent. Now, there's so many little rules with exponents. Those are like the big things, okay? So big number, the base, it can be negative. That's okay. It's kind of like mom and dad. If they do something wrong, can you say anything about it? No. You can be mad, but it's their job. It's their life, right? But if you're the kid, you're the little one, are you allowed to be negative? No, your parents are going to punish you if you have good parents, right? They're going to get you in trouble for that. Again, weird ways to remember things, whatever helps you remember. All right, quotient of powers property. So if I'm dividing and I have the same base, you subtract their exponents, right? This is an A, this is an A, they match. It's almost like you're playing the match game, right? When you're dealing with exponents, you play the match game all the time. Stuff that have the same base, I'm going to put them together. They're kind of considered like terms that way, right? So it stays an A, that part doesn't change, and then your exponents we subtract. So if I had 5 to the third over 5, it would be 5 to the second. Good. Because what's its exponent if it's not there? It's a 1. If it helps you to write those ones so you visually have a number, write them in. Math is full of unspoken numbers. Like if I just write a big giant X, what number's in front of that? A 1. What's its exponent? A 1. Right? If I have a fraction of a 3 and I say it's a fraction, what number are you putting underneath it? A 1. There are unspoken ones. Okay? Mathematicians are lazy. You're going to learn that. I'm a very lazy mathematician. If I can show you an easier way, I promise you I will, because I don't want to do all that work either. Okay? So mathematicians are very lazy. That's why we have so much shorthand in math. All right. We have the power of a quotient property. Right? So again, when I see something outside of a parenthesis, my first instinct is to distribute. Right? Same idea. Just like up here, but if I have a fraction I'm dividing inside here, it's okay. It does the same thing. It goes to the top and it goes to the bottom. Same idea. And the zero property. This is my favorite property there ever was. Why is this my favorite? It's so easy. Yeah, anything to the 0 power is 1. Now, you want to know what students do wrong all the time? They remember the 1. But they look at this, they go, oh yeah, anything with 0 is 1, so that's a to the first. If I wanted it to be a to the first, I would have written a to the first. Okay? So if it's anything to the 0, poof, it's gone. It's no longer there. If I want to make Carrie disappear, she's making me mad one day. I'm going to get rid of her. I'm going to raise her to the 0 power, because where does Carrie go? Bye-bye. There's just a number 1 left in her spot. Carrie's gone. Anything to the 0 power, gone. Okay? All semester, you're going to be my girl that I raised to the 0 power and got rid of. Okay? So just keep that in mind. Raising to the 0 power, see you later. You're out of here. That's how I can get rid of people. All right. So simplified expressions. You know, in math class, you always have to simplify as far as humanly possible. All right? And I do take points off if it's not simplified. Like if you leave 2/4 on your page, I'm going to groan at you, right? What's 2/4? That's a half. I want you to simplify. Okay? All right. So simplified expressions do not contain blank exponents or blank as an exponent. So what type of exponents are we not allowed to leave? Negative. It does not contain negative exponents. Or blank as an exponent. What's my favorite property that gets rid of people? 0. We don't want to leave 0 as an exponent. I can just get rid of it. Technically, it's a 1, but say that again. Correct. See, now my biggest thing with that property, like, it always throws people because they're like, where do I put the 1? Does it really matter half the time? If I have 3x to the 0, is that x Or that 0, is that on the 3, the x, or both? Do you see parentheses? No. Exponents is one thing else we'll talk about quite a bit. Exponents are only whatever they're next to. That's the only thing they go to. So right now, this 0 is only on the x. What's the exponent on the 3? That has a 1 on it. Okay? So by me saying that anything to the 0 power equals 1, so this entire thing becomes a 1, do I actually have to write it? You wouldn't tell me that's 31, would you? What's 3 times 1? It's just 3. So do I have to write the 1? No, I don't. The only time it really becomes a thing where I have to write the 1 is if I would give you like x to the 0 over 7. Could you tell me that that is just 7? It'd be 1 over 7. I have students every year who argue with me, telling me that it means the same thing. Do you want 1/7 of a pie, or do you want 7 pies? You tell me, which is more. Does it make a difference? It makes a huge difference. Okay? All right, so let's get into, oh, I didn't finish that, did I? Simplified expressions have exponents that are blank numbers. Close? Yeah. The whole, I know you're on the right track with whole. I know what you're thinking. But I'm going to disagree, and I want the word to be natural. Do you guys know the difference between whole numbers and natural numbers, Terry? How much higher than 0? A solid number. I like that description. Like if I ask you guys, let's see, try to learn some names here. Corbin, will you count for me, please? Just count. Okay. Did you guys hear what he started at? Naturally, where did he start? Did he count by 1, 1.1, 1.2? Someday somebody's going to like count wrong for me, and it's going to like throw this whole example. But he started at 1. He went to 2, 3, 4. He started counting up, right? It's where you naturally count. Those are your natural numbers. They're whole numbers. I hate that word, whole numbers, but they're, what'd you say, solid numbers? Solid numbers, I like that. There's no decimal, there was no fractions, right? And they went up into the positives. The only difference between natural and whole, think of a hole in the ground. What shape does it look like? What number does it look like? 0. The only difference between whole and natural is whole numbers include 0. It's the only difference. So can I have whole numbers for exponents? Am I allowed to have a 0 for an exponent? No. That's why I like the word natural better than whole. Whole numbers include 0, natural numbers does not. It's the only difference. All right. Simplified expressions have number bases with an exponent of what? The homework last night, one answer I read was 1 over 4 squared. And what did I say? I said 1 over 16 for those of you who wanted to change that. That's considered simplified. If you would leave 1 over 4 squared, that's considered not simplified because your number base has an exponent that can be simplified. So if I would change this to 1 over 16, now what exponent did I leave on my numbers? They have exponents of 1. Number bases have to have an exponent of 1. In other words, don't leave 4 squared. Don't leave 25, squared on your paper. Don't leave 5 to the 3rd. Actually tell me what those numbers are. Now, if you have 27 to the 32nd power, are you going to really tell me what that number is? No. That one's a bit ridiculous. But, reasonable numbers that only, I can fit in my calculator, you should probably actually tell me what those are. And it has fractions that are, you're not going to leave 2/4, are you? Simplified. All right, so now that we know how to simplify, right, what all my bases are, let's actually practice them. So if I have 2x to the 3rd y squared all raised to the 4th power. So notice the parentheses and the exponent is outside of it. That means that exponent gets distributed to everything inside, the same way you would normally distribute. So what might be helpful for some of you is to actually put that 1 on that 2. Because what happens, and we're going to do an activity with this tomorrow to get you guys some more independent practice, but what happens is students distribute it to the exponents they see, and they don't distribute it to the ones that they can't see. So sometimes it helps in the beginning to kind of write those ones in. So when we distribute, this is going to be 2 to the 4th. It's going to become x to the 12th. Good, you multiply when you distribute. And y to the 8th. My board decided to switch pens on me. Here we go. Is this done? Is this good? Can I circle my final answer and move on? Why not? What's not simplified? Good. 2 to the 4th. What is 2 to the 4th? 16? How'd you get 16? Calculator. That's an honest answer. I'm glad, though. What do you think a lot of people tell me the answer is? They tell me 8. Why do they tell me 8? 2 times 4. Don't do that. Okay? Remember, that means 2 times 2 times 2 times 2. And again, if you're not sure and you're not comfortable, grab the calculator. I'm okay with that. I'd rather you get it right because you checked yourself than thinking you're a genius and you get them all wrong because your basic math skills suck. Okay? All right, what about number 2? What do I do with that one? Do I still start that the same way I started this one? I can, absolutely. Some people are like, but wait, there's a negative. Don't I move that for? Ugh. My first instinct is to distribute. Just, like that's what we're ingrained to do. Go ahead and do that. We'll fix everything else later. Okay, so let's distribute first. Do I have any unspoken ones? Yeah, the 5 has 1. We got to remember those because people forget those all the time. All right, so if I'm distributing, I'm going to have 5 to the what? Negative second. Good. And then a to the, good, a positive 6. So that one, my negative actually went away. So that was good because 2 negatives make a positive. And then b, negative 8. Sorry, we're a little rusty. All those basic skills will hopefully come back to us. Am I good? Done? Why not? There's negative. So do I move them all? Why? It would make the a negative if I moved it. Yeah, so I only have to move the ones that aren't good, right? So I'm going to move the 5 to the bottom, so it's 5 squared. I'm going to move the b to the bottom, b to the 8th, right? When they move, they become positive. That's why I'm moving them, to make them positive. And then where does the a go? Yeah, he stays on top. Because if you think about it, right now the original problem was technically all over 1. So like he gets to stay on top A, everybody else gets to move to the bottom. Now am I good? No? There's a 5 squared sitting there. So a to the 6th on top. What is 5 squared? 25. And then I have a b to the 8. Yeah, you got to kind of go through that checklist in your mind. Make sure there's no negative exponents. I can't have any zeros for exponents. I can't leave a number with an exponent on. I got to like actually simplify all that stuff. How are we doing so far? Okay, decent? Oh, decent. I'll take decent. All right, number 3. 9uv to the negative 10th. All of that is raised to the 0 power. Just 1? I don't have to distribute that? Technically, if I distribute it, they'd all have an exponent of 0. So do I really need to? Am I allowed to see this and just do this and call it a day? I like those. Anything to the 0 power. This entire piece right here was raised to the 0. Poof, gone. My answer is just 1. Right? Carrie, to the 0 power. Poof, bye, Carrie. Just a 1. She's gone. Yeah, so like a whole page of those would be glorious. You won't get a whole page, but it would be glorious, right? 1, 1, 1, 1, 1, 1. Somebody would be like, oh, that can't be right. 7, 6. Something's got to be different. Yeah. You're right. I did made myself disappear. She's right, 'cause my name is Carrie. Spelled the same. All right, number 4. Ooh, there are 2 sets of parentheses. Should your first instinct still be to distribute? Yeah. So does that -2 distribute to everything? Just the first parenthesis, right? It's only attached to this part right here. All right, so we're going to distribute. Now, this is the points where your calculator is smarter than you want it to be. Thank you. All right, so when I'm doing -7 to the -2 power, it's going to make a difference how you write that. I just want you to be aware. Let's take a time out from this problem for just a second, okay? I'm going to take a little sidebar. Is there a difference between -2 squared, like this, and -2 in parentheses squared? If you got a calculator in front of you, type that in. I want to make sure you see this. So on the top, what is the very first one? The -2 squared, what does this answer? Nathan? -4. What is this answer? It's +4. And you're like, what the heck? Seriously, that's going to make a difference? And it really does. Your calculators are smarter than you want them to be, okay? Remember I told you exponents, they're a little snooty, and they only go to, like, what they're right next to? They don't like to reach out to others. They're just, yeah, I'm lazy. I'm like, whatever's right here. That's what's happening in that first one. In this top example, this exponent of 2, he's lazy. He's only attached to that 2. He doesn't care about the negative. He's ignoring him. So in this one, if you would expand that, that's a negative out in front, and then it's doing 2 times 2. That's what it's doing. But down here, you said, hey, you stupid exponent, include that negative. It's attached to it, right? You've put them in a parenthesis with it. Now this one's going -2 times -2. And 2 negatives make positive. Okay? So whether you put a negative number in a parenthesis makes a difference. So my rule of thumb, anytime you're dealing with exponents and you see a negative number, put it in a parenthesis. Like just automatically, oh, negative, put it in parentheses. That way you keep that together. Okay? So that's why I put this -7 in parentheses. All right, back to this problem. So we're going to continue distributing. That would make that m to the -6 and n -4. What do I do with all that other stuff? It's just going to come down with you. Do I need the parenthesis? Is there another way to show multiplication without a parenthesis? I could just put a dot. Remember, I'm lazy. So m and 7. Do I have any unspoken ones? Yeah, that m's got one. At least until you're really comfortable, I would probably draw those in. It's going to help you out. All right, well, that's a big mess. What do I do now? Put them in the basement? You could. I'll be honest, my first instinct next is not to put them in the basement. You can. That's just not the way I typically do them. Carson, what were you going to say? Combine them. I have like terms sitting up here. I have an m and another m. If it is a multiplication problem, which it is, what do I do with their exponents? You add them. All right, I have students who always struggle, like, when do I add them and when do I multiply? They usually understand when to subtract them. But, like, they always kind of get in that, I don't know what to do with them. If you see a parenthesis that you're distributing it in, that's multiply. Otherwise, it's not. Okay, so I still have this -7 to the -2. I'll worry about him later. But if I put my m's together, what is -6 plus 1? As -5. And then I have n's. -4 plus 7 is 3. So one of my negative exponents on that n actually went away. It's not positive. Okay? So next thing. Now can I move things? Yeah, I put all my like stuff together. So now any negative exponents I have, we're going to move those. All right. So anything get to stay on top? Yeah, the end of the third does. He didn't do anything wrong. He can stay there. All right, but the -7 and the m, see their exponents are negative? Those are going to move. Does the 7 itself turn positive by moving it? No, only the exponent does. So remember, parents can be negative, right? So the negative, the big numbers, those are okay. That's going to change that to a squared. And my m, instead of -5, now that's 5. That's why I move them, is to make them change to a positive. Yeah. Perfect. So then last, end of the third is going to stay there. I'm going to change my -7 squared as just a positive 49, and then an m to the 5th. I don't know. It's got a mind of its own. Does that a lot. So are we noticing kind of like a pattern to kind of how we want to attack these? What's always the first thing I'm trying to do first? I'm trying to distribute. So if you're somebody who likes like a step-by-step, here's what I do. First thing I would always try to do, if you can, and again, it depends on the problem, I would always distribute those exponents first if you have a problem where that needs to be done. And then what did we do? We combine like terms. So I might write it, though, as combine like bases, since that's what I'm looking to be like, is the base number. What do you do after you combine those like terms? What did we do? So in other words, I move your negatives, right? Move negative exponents. I'm not even going to use fancy math terms, man. I'm just going to move negative exponents. If they're negative on the bottom, where do they go? Negative on the bottom, I'm going to move them to the top. If they're negative on the top, I'm going to move them to the bottom. All right? I move my negative exponents, and after I do that, is it okay if I just write simplify, right? Like number bases, whatever. So I'm just going to write simplify. Just keep that last step a little general. I'll simplify from there. Okay, so that's kind of like your plan of attack. Distribute if you have to. Combine any like bases that you have. Move my negatives then, if any are still there, and then just kind of simplify whatever I got going on. That could kind of entail a few different pieces. All right. Number 5, -2x over y to the -3. So if I'm thinking through the steps I just wrote, step 1 was to distribute. Do I have anything to distribute? No. I don't have any parentheses. I don't have anything to distribute. Okay? Step 2 was to do what? Combine any like bases that you have. Do I have any like bases on problem 5? No. Okay. Step 3 said to move any negative exponents. Do I have any of those? Yeah. So what do I need to move? The y. Do I need to move the -2? Why not? It's not a negative exponent. Just be careful. A lot of people want to do that. All right, so the -2x, do they get to stay on top then together? They're good, they can stay? So the only thing I need to move is that y, and he's going to move up. So it's y to the 3rd. Then is there any more simplifying that needs to be done? No. I'm done. That's a 3. Oh, sorry. Did it copy funny? What? You guys okay? Oh, I'm sorry. It's a 3. We'll talk about it. It shouldn't. Sometimes these notes, I can almost see they look a little fuzzy for whatever reason, so there must be something in that. All right, number 6. Ooh, what the heck is that thing on the end? It's a fraction. Hey, is anybody else afraid of fractions? Everybody has fraction phobia? I find a lot of students have that, fraction phobia. All right. You know what? If I rewrite this in the most simplest of fashions, I bet it would make a lot more sense to you. What if that fraction bar is actually rewritten? What if I wrote that as h to the 6th, k to the 5th, and on the bottom was h to the 4th? Would that make more sense to you? Does that mean the same thing? Yeah, it does. What stuff's on top? What stuff's on bottom? Why didn't I write the 1 down? If you multiply by 1, does it change anything? No, so I didn't really need to. It's one of those unspoken ones again. Okay, now do we know how to attack that problem? Do you have anything to distribute? Kind of looking through our steps. Nothing distributes. Do you have any like terms or like bases? Yeah, we do. Right? We have some like bases. I can put my h's together. What do I do with their exponents? I subtract them. 6 minus 4. Now, I do want to point out one thing I know some students get a little tripped up on. When you subtract, it's always the top minus the bottom. Don't do it vice versa. Okay? Top minus bottom. All right, so when you're subtracting. And then also, by default, where do they go? They, by default, go to the top. So that's good to know. Just, again, side note. If I would have, like, x to the 3rd over x to the 7th, top minus bottom, that would be x to the -4. By default, that becomes x to the -4, which technically it's on top. And then to simplify it, where would you have to put it? Then it would have to flip to the bottom. It would become 1 over x to the 4th. Okay, so it's always top minus bottom. And then by default, they always go to the top. But then you may have to move them in another step. If you are comfortable to do all of that in one step and put them on the bottom as positive, that's fine. If you are like, it's too much for my brain to handle, write it down, and then move them in the next one. I'm okay with either. All right, so back to problem 6, though. So I have h squared. And then what do I do with the k to the 5th? Just drop it down, k to the 5th. Anything else? Nope, I'm done. Ta-da! Not every problem has to be like, a 30-minute long process, right? Are you ready for a brain break? Yeah? We need a break, right? Let's take a break. All right, so back at this, number 7. What is step 1? Distribute. What does that 3 get distributed to? Everything. Do you have any unspoken ones to worry about? Yes. If need be, write them in. So that's 3 to the 1st, that's an a to the 1st, that's a 5 to the 1st on the bottom. Okay? So if you're not comfortable thinking, like, I'm not going to remember to go to everything, write the ones in there. All right, but it will distribute to everything, and distributing means I multiply. And exponents only like their own kind, so they only go to exponents. So that's going to be 3 to the 3rd, a to the 3rd, c to the 12th, and then also distributes to the bottom, so it becomes 5 to the 3rd, and a to the -18th. So that was step 1, just distributing. All right, what was step 2? Like terms. So I do have some like terms in there, right? You guys see your a's? What do you do with the a's, exponents? Oops. I subtract them. Oh my gosh, I cannot draw a line where I want to. There we go. What's 3 minus -18? Very nice. It's 21. Stop and think for a minute. 3 minus -18. What are those two minuses side by side? That's a plus. Yeah, so be careful. 3 minus -18 is 21. By default, where does it go? To the top. So that's going to be a to the 21st. And I still have that c to the 12th up there. So it's always top minus bottom. Watch those double negatives. And then by default, it goes to the top. All right, so that was step 2. Step 3, move any negatives. Actually, don't have any left, so I don't have to worry about that. And then simplify. What do I still need to simplify? Yeah. What's 3 to the 3rd? 27. And 5 to the 3rd? It's 125. Does 27 over 125 simplify? Yeah, no, yeah, no. If you are terrible at simplifying, could you type it in as a fraction on your calculator and just hit enter and see if it simplifies? Yeah. Now, okay, hold on. Don't type in 27 divided by 125 because it will change it to a decimal. If you type it in as a fraction and then hit equals, if it will simplify, your calculator will simplify it for you. Okay. What? Oh, on the graphing ones, you hit the green button. See the green button? So hit the green button, and then 2 buttons above that is one that says y equals. Do you see it? It's 2 buttons above the green one. And then hit enter. And then it brings up the fraction. Okay, if you did not know that, you may want to take note. That's how you get a fraction in the graphing ones. Change answer to fraction, because this is faster. For me, when you're dealing with a lot of things, and as we get into bigger equations, like you'll want an actual fraction button as we keep going. All right, so does it simplify? No, it does not. But you always want to check for that, okay? Because you can't leave a fraction not simplified. All right, number 8. Ooh. Well, what do I do first? Distribute. Okay, so we'll start with that. So that -1, do I have any unspoken ones in this problem? Yeah, the d at the top. So that's going to make that d to the -1, because we multiply those. And then e to the -6. Where is the d to the 7th and e to the 3rd right now? Are they away from it? Can I put it all together? Top or bottom? Technically, they're on the top, right? If I made those a fraction, they'd be on the top. So I can just write them on the top. I think students understand it better when it's all kind of smooshed into one fraction. It makes more sense. And we can do that. Legally, that's okay. No, math rules, math laws. Legally, that's okay. I talk about that a lot. I keep saying every year, and I never actually do. I should get a math jail and like put in my corner. So every time you guys do something that is like not legal in math, make you go stand in it. It's really funny. Although half my class would be in there some days. All right, so here we go. So I distributed. Next step is like basis. Do I have any like basis? Yeah, my d's. Okay, so when I put my d's together, I get d to the 6 because you add your exponents there. And then these are the same too, right? Okay, what do I do with their exponents? Subtract. So what's 3 minus -6? Is 9. By default, they go to the top. So this is e to the 9th on the top. So do I have anything on the bottom? So do I need a fraction? I do not. And then that is as simplified as it gets. So I'm done. Some students try to move negative exponents before they put stuff together, and you can. It's nothing wrong with that. I just told you I'm a lazy mathematician, though, right? I did not move it first, so did I even have any to worry about at the end of this problem? No. You can do it. It's just going to give you extra steps. We're close, guys. We got 4 problems to go. We're close. We can do it. So number 9. Right now, that is written as 2 separate fractions. Do I have to keep them 2 separate fractions? No, I don't. Since it's being multiplied, it really doesn't matter. I can think of this as one giant fraction bar. Now I have my stuff on top, and I have my stuff on bottom. I'm just going to worry about that. All right, so my biggest thing with students, because you're going to see some problems today and some bigger ones probably even tomorrow, that they get really long, and there's a lot of stuff. And like you might have like a bunch of x's on top and a bunch of x's on the bottom, and like I don't know how to put all that together. I always tell students, like, simplify the top, simplify the bottom, and then put them together. Okay, like clean up one area at a time. Okay, don't clean house like I do, right? When I clean house at home, like I pick up something in this room, and then I walk in the living room and put it away, and then I'm like, oh crap, that needs to go in this room, right? And then I'm just like constantly walking all over my house, never really cleaning one whole room entirely. Does anybody else do that? Yeah, okay. It's not very efficient. It's really not. Eventually, but you know, I do the same thing. I'm just like, I see it and I just can't help it. But for math, let's clean up one area first, okay? Clean up top, clean up bottom, and then we can put them together. So on this problem, there's nothing to distribute. So when I go to put like terms together, let's clean up the top, clean up the bottom, and then we'll do the whole thing together. So on the top, do you have anything that's alike? The y's. So I can put my y's together, and that will give me y squared. I still have a 3, and I still have an x to the 5th. Does the order I put them in matter? What's 3 times 5? What's 5 times 3? Did the order matter? No. Multiplication order does not matter. Typically, we like to see the number in front. If I had stuck that 3 at the end, you would have been like, why did she do that? It looks weird, right? Technically, I could. It just looks strange. All right, on the bottom, anything the same on the bottom? The 15 and the 4, how do they go together? They literally just multiply. There's no exponents to put together, but that's a multiplication problem. 15 times 4 is 60. So if the bases don't match and they're numbers, just literally do whatever operation the problem is. They just get multiplied together. All right, so I did the top, I did the bottom. Does anything top and bottom go together? Yes, I have those y's. What's going to happen to my y's? They're going to cancel out. Why? If I subtract, 2 minus 2 is 0, and anything to the 0 power is, poof, it's gone. Technically it's a 1, but it doesn't really matter. So those are going to be gone. So I have 3x to the 5th over 60. Am I done? Last step is simplify. Does 3 over 60 simplify? That is 1 over 20. Now, I did not write the 1. Is it wrong? Why not? Is it implied? It's implied because there's an x here. Now, had there not been an x on the top, and I just wrote 20, is the y or the 1 implied? No. It's only implied because there's a variable up here that we assume that there's a 1 in front. Now, if you are more comfortable by actually seeing that 1, that's okay. I'm not going to count you wrong for that. Just know that I'm a lazy mathematician. I'm not going to write it. If I don't have to write it, I'm not going to. All right, number 10. Oh, that's a doozy. What do you do first? Distribute. Step 1 is always distribute if I can. All right, I only have one distributing part, so let's do that first. Remember, you do have some unspoken 1s in this problem. Don't lose track of those. So we're going to have 3 to the negative 2. Distribute again. We'll have m to the negative 2. And n to the positive 4. Right? Because negative 2 times negative 2 is 4. On the bottom, I still have a 10, an m to the 1st, an n to the 9th. On the bottom, on the other one, I'm going to combine my fractions just because it makes more sense to me. Right? It's a multiplication problem. I can do that. I can just one big old fraction bar and put it all together. Now, there's a lot going on in this problem. Okay? One room at a time. Okay? Let's clean the top. Is there any like terms that go together? I have m's. So let's put our m's together up here. So I have a 3 to the negative 2. My m's, when I put them together, will give me m to the 3rd. Good. But you add their exponents. I have an n to the 4th, and that weird 18 just kind of hanging on to the end. Can I put the 18 and the 3 together right now? Those of you who want to, what happens to the negative 2 as an exponent if you put them together? You're like, I don't know. Right? You can't. Since it has that negative 2 for an exponent, that exponents only go to what they're next to. It's only on that 3. So you cannot put it together with the 18 right now. Okay? They have to stay separate. All right, let's clean up the bottom. Anything down there that can go together? We have ends. All right, that's going to give me n to the 7th. I still have an m to the 1st. Can I put the 10 and the 2 together? Yes. Now wait a minute. Why can I put the 10 and the 2, but I wasn't allowed to do the 3 and 18? That exponent. Neither of these have an exponent that like needs something done to them. They have 1s on them, but that doesn't change anything. This one, that -2 is going to change that, so I can't do anything yet. These, there's nothing holding them hostage. They can go together. Does it become 12 or 20? It becomes 20. 10 times 2 is 20. They are not exponents. They are big numbers. All right, so I cleaned the top, I cleaned the bottom, and then if I put them together, is there stuff that goes together now? All right, I have m's that go together. So m to the 3rd over m to the 1st becomes m to the 2nd, and by default it goes to the top. Okay, then I also have n's. 4 minus 7 is -3, and by default it goes to the top. Anything I haven't used yet, it's still kind of hanging around. I'm just going to kind of write it all in. We'll worry about it in a minute. Some of you, again, if you are more comfortable on doing like 3 steps in one, I'm okay with that, okay? Because if it was me doing this problem, I would. But I'm just trying to, I don't know your guys' math abilities real well yet, so I'm trying to like hit every single step to make sure I don't lose you guys. All right, so I put stuff together. What's my next step? What's step 3? Move your negative exponents. Okay, what gets moved? The 3 and that n. Right, so the m squared stays up top. The 3's come into the bottom. The n's come into the bottom. I still have that 20 down there. And I still have that 18 on top. I'm going to throw him up front just because he looks weird on the backside. Okay, so all I did was take my negative stuff and moved it. That's all I was doing there. And if it helps you, I think some students, when they go to move things, they like lose track. Like, did I move everything? Did I use all? Like, they lose pieces. I think it helps when I circled them like that and showed what I was doing. Do you see all the pieces that I did not circle and did not touch? Don't lose those, okay? Write those down right where they were. They're still there. I just needed to move pieces. All right, so now I'm at the point of simplifying. Is there anything you see right away that's very easy to simplify? 3 squared is 9. And again, I'm really drawing this problem out. Some of you would do this a lot faster than this. I just want to make sure you see what I'm doing. All right, so I took the 3 squared, changed that to a 9. Any more simplifying I can do? 9 times 20 is 180. If you need a calculator, it's okay. No shame in that. Am I done? 18 over 180, does that simplify? To what? It'd be 1/10. So this all becomes, that becomes 1/10. If I simplify this to 1/10, and then I have an m squared on top and an n to the 3rd on the bottom. Do I need the 1 on top? No. If you have it, fine. I don't need it, though. Oh, that problem went on and on and on. Do you see how you could potentially do that maybe a couple steps at a time, though? Okay. I wanted to go very step by step for those of you who might need that. All right, what do we got? 2 to go? 2 to go. 11 and 12. Number 11, even before I get started, I see something that makes me very excited. I see the 0. What goes away? The s. So do I even need to worry about them at all? Can I just do this and be okay? Yep, sure can. I don't really need them. So, all right, get rid of something on my problem. All right, what do I do first? Distribute. Oh, don't forget there's an unspoken 1 on that s. So we're going to get r to the -6 s to the negative 2 and t to the 8th. Now, I have all this other stuff on this fraction to start with. Can I kind of put it all together here? Is that okay? Where is all of this that I already wrote? That's all on top right now. So I still have a 2r squared on top, and I have a t to the 9th on the bottom. Good. Next up is your like bases, and I do have r's that I can put together. So 2, what's that going to give me? R to the negative 4. Do I have other things I can put together? Yeah, I can put those t's together too. 8 minus 9. So it's top minus bottom. 8 minus 9. It's negative 1, and by default it goes to the top. All right. Step 3, move any negative exponents we have. So I'm moving the r, and I'm moving this, right? What about the 2? It's on top. I have a lot of students who assume that, oh yeah, it's connected to the r. No, it's not. There's no parenthesis holding it on there. That's an unspoken 1 on that one. So he gets to stay on top, and the r moves to the bottom, and so does the t. Oh, I did forget the s. Thank you. S to the negative 2. Sorry. That one's going to move to the bottom too. Thank you. I totally lost him. And I even did, like, I marked all the things I moved, and I still left him over there. All right. One problem to go on your own. Take a few minutes and try it. Remember our 4 steps we wrote down. You guys will be okay. All right, guys. Let's go ahead and talk through this. Some interesting things I kind of saw. I'll talk about all of that. All right. So first thing, most of us did just fine. We distributed, right? So we should get a to the negative 8. So kind of look through yours as I talk through and kind of look at your work. And then we'd have b to the negative 14, c to the negative 12. And then on the bottom, you should have a to the negative 6, b to the 2nd, and c to the 6th. Right, that should have been your first step in distributing. Okay? From there, I'm going to look and see that I have like bases. So if I'm putting like bases together, my a's, some of you may have had some issues with some basic math going on in here. It's okay, because it's negative 8 minus negative 6. That's going to give you negative 2. By default, they go where? They go to the top. So that's going to be a to the negative 2. If I put my b's together, negative 14 minus 2, negative 16. By default, goes to the top. And then my c's, negative 12 minus 6, negative 18. By default, goes to the top. So I really have nothing on the bottom right now. All right, step 3 is to move negative exponents. So all 3 of them all move to the bottom. And here's where some of you had some issues. So a squared, b to the 16th, c to the 18th. Guys, don't pack up. We're not done, okay? Now, here's what I saw a lot of you do. Like, you knew they had to move. Like, you literally had them all written negative, and then I saw that you put a line, and then you wrote them on the bottom, and then you looked at it, and then you just circled your answer. Something's missing. There's a 1 on top. Yeah. Without that 1, I don't know that it's on the bottom. Okay? That 1 is that placeholder that shoves them down to the bottom of that fraction. Okay? Something's got to be there. All right. So that is the end of the notes for today. Homework tonight. So you guys ready? Yay! Yeah, both.